At some point, I probably should explain as to what I'm actually doing, so come on in here and we'll take a look. Nylon Brigade was originally designed to use a UHMW armor band. In the last version of the robot, though, I switched over to a 3D printed nylon piece. Of course, with 3D printing comes with some more advanced options for attaching the armor to the chassis, and that is what I'm kind of prototyping up over here. So let me just finish my hacking design process I got going on right at the moment, and then we'll head up to the computer. On the 3D modeling side of things, all I really need to do is take what I did in real life and move it over to the computer. That involves is dropping down the height of the roof supports to where I got them more or less after I kind of cut them apart. And I'm also going to remove several pieces from the structure that were originally used solely to attach the armor to the robot. I am then making one additional tweak on the side of the chassis just to help protect the receiver a little bit more now that the armor configuration has changed. When it comes to the actual armor band, all I really need to do is add little tabs that line up with these new posts. And then once it's all said and done with, we're going to send it over to a 3D printer and see what happens. Previously, the armor band would attach with bolts at several points around the chassis. Now with the new armor, it just slides right over the posts that hold the lid of the robot on. The main advantage of this design is actually just maintainability, because what I discovered is that pretty much repairing any part of the robot required me to remove one or more of the bolts of the armor, and that's assuming I didn't have to replace the entire armor itself. This way, I take the lid off, I'm going to remove a few extra pieces I'll talk about in a little bit, and then the armor band will come right off for easy maintenance and easy replacement. And when you've got 15 minutes or so between fights, easily replacing the armor and faster access to repair other parts of the robot is always a good thing. Now there should be a little bit of a weight bonus because of this new armor setup, because I am removing 5 heavy bolts and replacing them with slightly larger of these little brass standoffs. I think maybe 5 to 10 grams in savings is what I'm getting, but that's not a bad thing either. Well, what I just did there solved the last problem floating around inside my head, which is that if a vertical spinner hits the side armor, it's going to put a lot of pressure on these 4 bolts holding the entire robot together. And these little pieces here are just EVA foam that when placed in between the armored tabs and the top of the robot, they're going to absorb some of that energy impact. At least that's what makes sense with the physics model going inside my brain. The obvious disclaimer being that model may not be 100% realistic, if any percent realistic. But, you know, it makes you feel better. So I'm going to run with that. Maybe at some point I should do some real testing of that, but that's definitely not for this video. I mean, one last thing before I sign off here, case you guys aren't really familiar with this particular tool, I'm not sure if it's really a common robot thing. I was using this earlier to cut through the chassis. This is called a razor saw. It's used for cutting through thin, lightweight materials in a very precise manner. This particular version was by Games Workshop for the Warhammer stuff, but you can find similar tools at hardware stores or online or wherever you can buy saws. They pretty much sell that kind of a thing. All right. So if you want to see me finally solve the problem with the weapon cage here, that's going to be the next video in this series. So hit subscribe. And until then, I'm Jason, the creator of Team Rocket Robotics. Thanks for watching.